Well,
of
this is so
rail natter.
exciting.
I know, right? It is exciting. It's happening. I think, right, so first thing I need to do is go, can everyone hear us? Please tell me if you can hear us. And is the sound okay? But I think that's it. It's happening. Yeah. People are good. I've got to now wait 30 seconds, so we have to like talk amongst ourselves. um, here we go. Can you hear us? This is super professional, as ever. Um,
Oh,
right,
my phone's just gone off to tell me I'm doing RailNet.
Oh, there we go. So that's it.
It's official.
RailNet, it's official. It's happening. Can you hear us? No. If I go like this, can you hear us now? Yes. People are saying yes. There's lots of yeses. David Shearers is here. Oh, the whole crew. So my favourite bit, I think I've started saying this in every episode, but I forget because I have a memory I have a very selective memory for these things. Is the chat that happens at the start? Is people are just chatting away? People have been chatting away. We've got 40 people just chatting away to each other in the chat already before we've even started. And here we are.
What's the mood like in the chat room?
They're just chatting away.
As long as it's not hostile.
It's not hostile. People are saying there's no us yet because they don't hear Melanie, but that's just because I'm the one nattering and I haven't given Melanie a chance to say anything. Melanie Osborne is here, everyone! Hooray!
Hello, everybody.
Woohoo! Postage stamp view. Yeah, okay. Everyone can see postage stamp view. Let's go. This is it. We're doing it. So I'm going to go. We're next to each other. Hooray! I've got my earphones in because it stops echo. I have the lapel mic, and I have a cup of coffee. I made an instant coffee, but the instant granules stuck together. So this is about as strong as one of Dina's sort of espressos that she has. So
where's that on the brown scale?
Oh, it's about. I'm going to pour it over
beige, that is.
yeah, it's pretty beige. But that's only because I had to make it milky because otherwise I'd have collapsed from the amount of coffee in it. Anyway, David Shearers is saying that we love signalling engineers. Stevie's saying that Stevie and Selby's saying they're never hostile. This is a lot of signalling love going on. So excellent.
Fantastic.
So today we are going. Let's go back to the presentation with side by side. Today we are going to be talking about Melanie. You came up with this title and I absolutely love it, which is we're getting trains from A to B without crashing into stuff or each other. I mean, there is no more simple
No,
way.
well, it's a really complicated field, and it's hard to boil down when you're at a party or giving a presentation to uninterested school kids. So yeah, I've been working on that one for a little while.
It's good. It's good. The only challenge I had was squeezing it onto the page, but that's for me as the skilled and accomplished graphic designer to stress out about. So let's. At some point, I'll get really slick with the production quality, or I'll employ someone better than me to do it. I think let's get started. We're 3 minutes in to the technical time for Rail Natter. I've been talking a lot, but I'm going to shut up very soon. And the way that I can shut up is probably by getting us started. So welcome, everyone, to tonight's Rail Natter. And there it is, the Intercity 225, fading away. Bit of Ivor the Engine cheering us up on a Wednesday evening. So yeah, I'm pleased to say Melanie Osborne's joined us to talk about signalling. Before we talk about signalling, we have to talk about depressing stuff and the news. Well, actually, it's not depressing. Depending on what your point of view is, it's not depressing at all. So I've moved my buttons around, so I'm trying to remember what buttons what. First things first, beaching reversals, whatever that means. The Department for Transport announced, this is the news, that the Department for Transport have announced a very strange and confusing list of things that they're going to reinstate, including several lines that currently exist and run passenger services. So we're going to be talking about beaching next week. We could talk for hours about this and unpack it, but that's been announced. Go and have a look at it. More interestingly, from Melanie, is news about trains, and particularly trains that they're fitting ETCS equipment into, which we'll talk about maybe later. Will we? Perhaps. So this is DB Cargo, or DB, whatever they're called now, DB UK, have just put out a contract to fit the rest of their train fleet with ETCS equipment. So that's in-cab signalling equipment, right, Melanie?
Absolutely, yep.
Yep, lovely.
Where are these trains running?
So this is their whole freight fleet. So there's loads of Class 66s and 47s, and all the kind of freight fleet, and DB run the largest freight kind of locomotive fleet UK wide. So I think they're preparing them for the fit so that they will be able to run on parts of the network that'll start being ETCS enabled. So, which I think is still, other than the Cambrian line next to my parents, I think that's still basically the southern end of the East Coast Main Line, which will be the first proper rollout. Although I don't know how long. Anyway, we'll get there, right? We'll get there.
We'll get there.
We'll get there. I don't want to hog with the news. But the other news is also signalling news. Is that Alstom in Germany have been trialling what's known as Level 3 ETCS, or kind of a bit like the DLR, the Docklands Light Railway in London, where there's no driver necessarily. Well, they're trialling this in Germany now. They're planning to trial it in a sort of a protected environment, but with service trains with passengers in it, which is quite exciting, because I thought this was a bit further away, to be honest. Closed system, fine, but regional railway is a bit more interesting. So, yes, the news. Yeah, right. So that was the news. I'm not going to do. I'd always end up taking about 15 minutes of the news. I'm not going to do that this time. I've now talked relentlessly, and you've not said anything. So, Melanie, tell us about yourself. Tell us what your background is, some of the things you've been up to, and introduce yourself to the Rail Natter hubbub.
Well, I worked in a call centre for a lot of years, and I decided that I wanted to be an engineer because working in a call centre is an awful job. And I happened to be on my third choice of work experience, and I met a guy who was setting up a rail consultancy, and we had a nice chat about the Beatles. And he said, "Do you like the Beatles?" And I said, "Yeah. Who doesn't like the Beatles?" And then he said, "Do you want to come and work for me?" And I said, "Yeah, all right." And I don't know how many years later, 18 years later, I'm still a rail signalling engineer, and that was one of the happiest accidents of my life. It was I love rail signalling engineering. It's never boring. It's never dull.
Yeah.
And thinking about this presentation that I've been working on and coming on here, I realise there is such a lot I still don't know, and I've got 18 years experience, and I'm quite frankly dreading the questions because I think it will be I don't know to a lot of them because it's so massive.
And it's a constantly diversifying field. I mean, railway engineering more broadly is constantly diversifying, but signalling particularly, it's going through quantum surges in sort of development and changes and sort of, yeah.
Well, you spoke about ETCS, and in my mind, it's like nuclear fusion. It's always 40 years in the future. It's always round the corner, but we're never quite getting there. So I'm fascinated about this Schenker initiative to fit their fleet with it, because that's lovely. But I think one of the bars to actually rolling out ECTS over the whole country is that it's too expensive to fit it inside the trains.
Yep.
So I'd love to know what they know that rail signallers don't know yet.
Yeah, Network Rail have paid for it. So Network Rail have paid a huge. So they're paying DB as a trial, as DB is the biggest freight thing. I think they're trying to, because it's that momentum, isn't it? So ETCS, that's European Train Control System. Is that right?
Yes, it is. Yeah.
Yeah. So this is part of the wider package of the three. So signalling, I suppose railways. Oh, you know what? I'm going to shut up. Because I've got in my head like the three C's, which used to be what was called S&T, and now it's command, control, and communication. Is that right? Is that right? The three C. Anyway, and that's what
we still call it S&T.
Yeah, well, this is it.
Maybe this is starting in the north and working south.
Yeah, in the real, it's still S&T in the real railway. Anyway, right. So let's go back to the presentation, shall we? So there's that nice regional railway train. So, oh crikey. We have a picture. Okay, right. So I'm excited. So without further ado, we've got kick us off with talking about moving trains around without them bumping into each other and stuff.
Yeah. So on Saturday, I was sitting at my desk thinking, right, I'm doing a signalling presentation. I've done lots of signalling presentations, but never a presentation to a willing audience. I've done lots of school kids, brownies, university students, careers fair stuff, but never to a willing audience. And I didn't have any pictures of signals. And I was actually on the Dorman catalogue thinking, can I steal this image to stick in my presentation. And I had a stroke of genius, and I thought I'll ask the S&T Facebook group if anybody's got any pictures of signals. And my phone just went berserk with people hitting me with literally hundreds of pictures of amazing signals, and trying to whittle it down to, I don't know how many we've got here. Less than 100 was quite something.
Yeah.
So these are all generously donated, and we've got everything from the Victorian right up to the very modern LED signals that are capable of displaying multiple colours. And yeah, we've got pretty much every permutation there of wonderful signals. And in my job, I've been continuously employed doing many interesting projects, but I've never really done any signals. I've done a couple of renewals, but opportunities for going out on site and taking pictures of signals have been very few and far between. So thank you, S&T Facebook group, for all these amazing signals.
Yeah, because there's all sorts there. So yeah, see, my experience as a P-way engineer, the main thing I do with signals is try and avoid knocking the head off them with a train. So I like doing gauge clearance with signals is pretty much most of what I do, and the occasional speedboard positioning. So I don't get much signaling action either, because it's the fun. You make colourful lights, right? It's good stuff.
Yeah. What's so hard about that?
Yeah.
And the answer is it is really hard. You've got to consider so many things. Can we have the next slide, actually?
Oh, yeah, go for it. So on this slide, we had pictures, all sorts of different gantries and little discs with a thing on them, and I quite like the little one with a dot on the front, the simple one that does multi-aspect, I think, or multiple colours, but it's on a little. It's quite an American-looking thing, actually, but I quite like those.
Yeah, it's fantastic, and it comes on a trunnion, so it sort of
falls, so you can look after it, which is very important. Yeah, nice.
You don't have to go up a ladder.
Yeah, exactly. Which gets rid of the annoying ladders, which then have a padlock on them. Anyway, yeah. So right, next slide. Tonight is all about digressing. As Melanie, I've seen you pop up before on RailNet, so you know full well what you've got yourself into. So I don't feel too bad about that. These are nice.
Yeah, well, these are just the really pretty signals. The largest one there with the at the top with you can see the hoods, which is really nice.
Yeah.
So your train driver needs to see the aspect from a long way away, and you can't be having the sun blocking it out or blinding you. So those are some quite long hoods on that one.
Yes.
But yeah, these are just aesthetically pleasing signals with sunsets behind them.
Yes, the sunsets and snow are they're on point. Yeah. It's very good.
And the one in the bottom left corner, that's got what we call a feather on it. So that is you'll have a route straight ahead, or if the feather's lit up, that means you'll be going in that direction. You'll be taking a route, and that often means slowing down. Signals. Everybody here knows the thing about railways is that trains run on lovely smooth wheels on a lovely smooth rails, and they can't stop very easily. They can't stop when they see something in front of them. They have to have a very long what's the word I'm looking for?
They just need a big spacing, don't they? I mean, big space, yeah.
So you've got 1,000 tons of train going 125 miles an hour, and the rule of thumb is it's a mile and a half to stop. People that do schemes work these things out minutely, but 125 miles an hour, a mile and a half to stop is not unreasonable. And of course, you're trying to cater for all different trains. You've got very lightweight little pacer trains and 2,000-ton freight trains, and you've got to fit all those on your network. So signals are performing a lot of functions.
Yeah. And yeah, I mean, these two pictures, both these two slides, it's just the variety of signals available. It's not just that they're different kind of styles and manufacturing and I think, in fact, I've got a question while we've got these ones up related to that, which is are there still lots of different regional variations in the type of signal used? Like, is there still preference across the like different preferences across the country?
I don't honestly know, but my suspicion is yes, because it goes on the network rail RAM is very influential,
Mm-hmm.
and if they really like a particular piece of equipment or don't like it, then they wouldn't want it on their patch.
Yeah. Yeah, so that's the root. So that's the asset manager, the root asset manager, the
Yes.
network rail RAM.
Sorry.
Yeah, and that's right. And they're and so they're it's the same for track. What they say essentially goes. They're very much in charge of what the infrastructure looks like, because they're really the ones that get told off when it breaks. So they're quite. It's quite important that they're happy with the infrastructure you're giving them. If you're if you're a designer or developing some change to the network, they have to like it.
And the other thing is these things change so slowly. So in almost 20 years of doing this job, I've done a couple of replacements. I've not been involved in any big re-signalling, because this stuff's built to last. Yeah. And that's why we have so much Victorian kit left around, because the Victorians, as you know, really went for it, and bequeathed this amazing system.
Yeah.
And if it ain't broke, don't fix it.
Yeah, yeah. And I suppose we're going to get to this in a later slide, but broadly, I suppose signalling principles are a bit like the fundamentals of track infrastructure. And actually, the reason why signalling sort of is still doing the same thing it did when it was first introduced is because actually the basic principles are pretty sound in keeping your trains apart from each other. Yeah. So shall we? Yeah. So we got some nice pictures of snow. There's a signal there with different coloured lights on it. I know these are all red, which is good because it means they've all been taken during possessions. Just, if there was someone taking a picture from the 6 foot and everything was green, I think we might need to. That might be.
Yeah, we might need to make a phone call. Yeah. So you've got your train running along, hopefully seeing green signals all the way. You don't want it to crash into anything on the same line. You don't want it to be struck by a train joining the line. You don't want it to hit a car or person on a level crossing. You have to regulate the speed so it's going at the correct line speed, especially over points and through stations. And you need it to stop at the station, or hopefully not in between stations. We aim for not in between stations, but I suppose we've all been on trains and the signals need to make human error. We need to make them fail safe. We hope that they do a right side failure. Do you think everyone knows what a right side failure is?
Oh, that's a good point. Yeah, so we've got a bit of echo in the sound there, Melanie. I don't know
so the right side failure is the inconvenient one, the one where you're stopped at red. And hopefully most of our failures are right side failures. Something's gone wrong somewhere, the signal goes red and the train stops. A wrong side failure is when something dangerous happens and something has gone wrong, the signal hasn't gone red, and you have a train in a dangerous position. That's a wrong side failure.
Yep. Sorry, we've got a bit of an echo on the audio there, Melanie. Has something changed on the sound? Because it wasn't doing it before. Just on
the... Nothing my end, I don't think.
Oh, okay. I'll just check that what am I doing? Is anyone else getting an echo through on the sound? Yeah, I think your sound cut out briefly. I think we heard everything you were saying there. Very briefly cut out, but I think we're okay. So everyone's following that, which is good, and the echo's stopped, which is good as well. So that's fine. Yeah. So do you want me to go to the next slide then, Melanie?
Oh yes, please. Yeah.
Yeah. So, right, a diagram.
Oh yeah.
We've rationed pixels a little bit here.
So the signals that we've just been looking at, they are part of a fixed block system. So probably most of the audience will be aware that in the first days of trains, they used to run them on the timetable. So you have a train leaving at clock face interval, maybe every half hour, and half an hour elapses, they send out the next train. And the obvious danger here is if the train breaks down or isn't moving as fast as it should, the train behind is going to smack into it. Now, one of the many wonderful things about signalling engineers and I guess rail engineers is that we learn from our mistakes.
Yeah.
And the early years of train travel weren't the safest. And I'm really pleased to say that we have one of the safest railway systems in the whole world at the moment, and nobody has died for a considerable amount of years as a result of railway systems. But it wasn't always the case. So not long after we started running trains around our wonderful railways, we came up with the idea of signals. And rather than having or leaving it to chance. And signals form a fixed block system. So you carve the network up with lights and you don't pass a red light. But the problem with this is that how many blocks do you want to carve it up into?
Yeah.
It's nice to have really long blocks. So you've got very, very few signals and track circuits to maintain and fewer things to go wrong. But if you want to get more trains on, you want smaller blocks. And ideally, if we look at the bottom slide, if we really squint into the screen,
yeah.
Now this is what ETCS will be. It will be a moving block, so you won't have lights on the side of the railway. You will have a system of Balise's little receivers in between the rails, and the system will know where the train is at all times. It's in-cab signalling, and the train will be the block, and the train behind it will be following it just beyond braking distance. So that little blue curve there is the braking curve of the train. And all trains have different braking characteristics. Freight trains will take a lot longer to stop than little trains. So you can get many more little trains in your moving block system, and even more freight trains. And it's a fantastic system. I can't wait for it to...
when it does eventually appear, yeah.
Yes, yeah. But I'm not holding my breath. And in all honesty, I think it might not happen in my career. I would love to be proved wrong, though.
Yeah. Certainly on the existing network. It's there are a lot of hurdles to still jump through, and most of them aren't technical. They're political and sort of organisational more than the.
Yeah. Well. Politics thinks very short term. It thinks on elections, and Network Rail have these control periods which are longer than the electoral cycle. So to get money for a project that nobody's going to get credit for, that's currently running for election, is difficult, isn't it?
Yeah. Well, it's the drum that I keep banging about, the fact that the main problem the railways have is they don't have a plan at all, and this very much feeds into it. If you don't have a plan for delivering a massive strategic change to the infrastructure of the railway like this, but also to the rolling stock fleet, it's just never going to happen. You need the right people in the right place, and without a long-term plan, you can't do that. So we've had a few questions, if I may.
Oh yeah,
that's right. So we had a good question from in fact, we had a couple of interesting questions about, let's see, block size. So and I think you partially answered this already. But, Matt Reed asks if there's a set block size.
It depends on the route. I'll be talking a little bit more about it in a few slides time. But if you've got a nice big deserted piece of railway like the wilds of East Anglia that you don't want to push many trains through, then you can have nice big blocks. But in somewhere congested where you want to cram lots of trains through very complicated movements, like Birmingham New Street, you want the smallest blocks possible to cram as many trains in.
Yeah, So and then kind of feeding into that, Michael C asks, could a really long train occupy 2 blocks at once? How would the signalling system react to that?
That is a really good question. We're going to talk about track circuits in a minute. Hang on, let me see where my slides are. Yeah, can I answer that one when we come to track circuits?
Yeah, we'll solve that. We'll save that one up because it's a good one. So there's okay. So Matt Reed has asked a question about which I'm going to answer, which is about how much more capacity a moving block gives the existing railway. And well, I mean, Melanie, you might have a view on that one, but I suppose mine is it depends. So, for example, at the southern end of the West Coast Main Line, basically zero, because the existing fixed block signalling is so good that you have such short headways that actually ETCS won't make a difference. I think the change from green to red is about 90 seconds on the West Coast Main Line at full speed, which is tiny. In some areas, it'll make much more of a difference, like 10
the
to 15%.
The textbook answer is, sorry.
Yeah, no, go on, yeah.
Yeah, the one they put on the glossy brochure is you can get 40% more out of our existing infrastructure.
Yeah. So all of the people...
Take your cynical hat off.
yeah. 40%. I suppose if you were going to introduce it in East Anglia, as you've just been describing, maybe. But no, I think about 10% is a good average. Certainly from the people I've seen. So from the people I've seen who are timetable planners and have looked at the modelling for it, it seems like there's a lot of optimism about ETCS. But the reality is that to get lots more trains running, you need more steel as much as upgrading the signalling system. Anyway, right. It's very good. Moving block is it's useful for all sorts of reasons other than just pure capacity, of course. Like traffic management, for example. You can yeah, anyway, I digress. The only reason I answered that one directly is because it comes up a lot, and I think ETCS and ERTMS are the future because we don't have enough signalling engineers to replace everything with fixed block traditional signalling. So we have to do something different. Anyway, right.
Well, I really welcome the digression actually, because I work in an office with signalling engineers, and we're all in our silos. And occasionally we'll have a chat with the guys that work on the electric and power side, but we don't actually have any P-way engineers or timetable planners in our office. So and that's why this is such a lovely forum to come on, because you're getting questions and information that you wouldn't otherwise get.
Yeah. So you've got David Shearers of Rail Engineer fame, amongst other things, pointing out that moving block is great for metros and for kind of similar performance systems, but it does on a mixed traffic railway. Infrastructure configuration is as important as kind of moving block, and it's about, I mean, as you know yourself, the railway is a system. You can't just improve one thing and expect it to fix everything. It's like a lot of people say. Both of us here, we both support electrification, but electrification doesn't solve all the problems. I'd happily, I don't know what P-way stuff is there. No one ever does anything nice for P-way. You could create grade separated junctions everywhere. That wouldn't solve all the problems either. Although it would put me in work for the rest of my life. So right, fixed block, moving block. Would you like to move to the next slide, Melanie?
Yes, please. Yeah.
Cool. Right, here we go. Oh crikey. Yep. Right. Learning. Yeah. We have a picture. So on the screen now we have many crashes.
Well, this is all the same crash.
Oh, is this all? Right.
This is all Quintin's Hill.
Yeah.
Yeah. As I mentioned earlier, I mainly talk to audiences of young people, and something that really grabs the attention of young people is death and gore. So they always remember this bit and start to look a bit perkier when I talk about rail crashes. So Quintin's Hill was 1915. It's the worst train crash ever in the British Isles. More than 200 people died. As you can see, top left there. I'm a terrible signalling engineer. I'm going to write this down. I put left and right. I have real difficulty with left and right.
Oh, I have to do this every time. I literally have to look at my hand with the L symbol to work out which one's left. I just have no idea which is left or right.
The thing is, my son showed me this, and I said, I'm looking at it, and either of them could be correct.
Yeah.
Anyway, top left, you'll notice that the carriage is on fire. The carriage is made of wood. It's a troop train. You've actually got an express, a local train, a troop train, and another train. It's a 4-train pile-up. The troop train was made of wood. They made a lot of carriages very quickly for the war effort, and they lit it by gas. So what was already a horrible crash involving 4 trains got a lot worse when the carriages caught on fire. And of course, this is in days before telephones, air ambulances, any kind of emergency services. So these trains crashed as a result of the inquest found that it was the guys in the signal box not really paying attention to the rules. They bent or broken a few rules, and it's the Swiss cheese model of all the different things that they've done wrong. All the holes in the Swiss cheese have lined up, and there's a horrific train crash. And there's this enormous bang, trains are on fire, and people ran from the local village and farms to see what the fuss about was, and then they ran back to their farms to get saws so that they could come back and cut people from the wreckage, because there's this enormous tangled fiery wooden metal mess with people trapped in it, and it's a really tough call. Would you rather have your leg amputated or burn to death? So there were amputations going on site, and one of the main recommendation to make sure this never happens again from the inquiry was that track circuits are introduced. Now, track circuits had been invented at this point,
okay,
but they were newfangled technology, and I guess a lot of the railway companies didn't really see the need yet. But this accident was a key factor in rolling out track circuits, which form the basis of our signalling systems today. May I have the next slide, please?
Oh, yeah, sure. Oh, I like this. I see lots of gubbins on screen right now. Dusty gubbins.
I love this dusty gubbins. I adore it. When I was at university, I did a degree in electronic and electrical engineering, and I imagined myself working at Hewlett Packard and doing something involving flashing lights. And this was all a complete revelation when I came to work on the railway. Top right there, we have state-of-the-art Westplex system right next to Bakelite relays.
Yes. It's a sharp contrast. It really is. It's brilliant, though.
Yeah,
This is on the railway. This is what part of what makes it so fun, right? Is that you're working in this. I'm working on. I've got one side. I've got slab track, state of the art stuff going in, whatever it happens to be, and then I'm transitioning it. I've got some junction. I'm transitioning it off onto like timber sleepers with bullhead, and the rails are from 1947 or something. It's part of the fun and part of the challenge. It's great.
Yeah, I completely agree. The top left there, we've got some shelf type relays, and I think they were state of the art in the 1930s, and they are interfacing with a lever signal box with a lever frame system. So we've really got all the generations here. Bottom right is a TDM cabinet that is fitted in a lever frame, and the TDM brings a signal from the next mechanical signal box up. Sorry, I should have explained that a lever frame is one of the old mechanical signal boxes. Gareth, do you find that sometimes you can't remember what it's like not to know anything about railways?
Yeah, when it just sort of courses through your veins and you have to sort of step back. I suppose. Yeah, I do when I'm teaching is when there's like a reset switch. But then you've got to you can't go too far. What I find is the middle ground of like talking like I've just forgotten the English language and talking like I'm speaking to someone who knows lots more than me about railways. I find that grey area is quite tricky to pick a spot when I'm teaching. So yeah, I know exactly what you mean. So TDM, is that the same TDM as in like, is that time division, or what does TDM stand for?
So it's
Oh, you cut out of it. Was that time division multiplexing?
It is, yeah.
Yeah.
A long string down a line, and encoding it at one end and decoding it on the other end. But this very fancy box of flashing lights is taking a signal from a mechanical signal box up the line, bringing it to the mechanical signal box that it is situated in, and it is ringing a brass bell for the signaller. It's got a little it's attached to a relay, and it dings a brass bell. So I mean that's one of the wonderful things about signalling engineering and all railway engineering, that you're interfacing the old and the new. And bottom left is something I'm doing at the moment on London Underground, and this is a 1968 control panel for a tube train depot, and it is falling to pieces, and I'm involved in doing a what's it called, a programmable logic controller system to replace it, and it won't be as pretty as it. Can you see it's got a little clock at the top?
Oh yeah, right in the mid. So in the middle of the image in the bottom left is a little clock. Yeah.
Yeah, the hands have fallen off. Isn't that adorable?
So we've got lots of people asking. So in fact, we've got people are really enjoying this slide. There's a lot of love in this slide. In fact, we've got a lot of people who must have been working on some of this kit. We've got people asking if this is Northumberland Park depot panel on the bottom left.
It might be.
It might be. There's a potential that Melanie's contractually obliged not to answer some of these. In fact, lots of people. There's a lot of love for this slide. People are enjoying the aesthetics of, and I suppose to an extent you're replicating. I mean, you're replicating stuff for an existing signalling workforce, so you don't want it to look too radically different. Even if you're moving from like a Bakelite or a wooden painted enamel panel to something on a computer screen.
Yeah. Totally. I mean, the depot control system that will actually be moving onto a computer screen, but we're in the design. We're taking into account what is already there and trying to replicate that on a computer and mouse system.
Yeah.
And that's one of another reason why you don't want to upgrade everything, because there's a lot of training for not only your operators but also your maintainers.
And in fact this comes, not that I want to keep coming back to thinking about the future in ETCS, but I think possibly the main challenge is actually in training drivers between both systems, because actually you need more drivers than you need to operate this steady state of the railway. Just like a lot of the challenges we've had on the timetable problems and the meltdown in December last year of timetable were related to the interface between drivers trained on some stock and trained on other stock. That's just going to be like that, but tenfold if you've got everything shifted. Anyway, yeah. So
someone told me a lovely thing about train drivers. Apparently, an idiot can drive a train, but it's the stopping that's the hard bit. That's the where the genius takes place.
Yeah, that's where the genius and the skill takes place. Yeah, I could very much. And in fact, we've got a few train drivers on here who can probably relate to that. Hello to all of our train drivers or train engineers if you're in the US. Although that name makes no sense, North America. Stop calling your train drivers train engineers. What do you call your engineers? Anyway, right. So
this is all part of going back to Quintin Sill.
Yeah.
Stuff evolving, and we're trying to take, where we can, the human out of the equation, because I don't know if you know about safety integrity levels, but a lot of the new systems are safety integrity level 4, which is like really safe nuclear submarine standard safe, whereas humans are safety integrity level 0. So we try and cut out the human element.
For all the unionised people watching, that's not because, just like the Luddites, it's not because we want to displace you entirely from your work. It's because we don't want the man blaming you for accidents. So if the capitalist in charge can easily blame you if you're an integral part of the signalling system.
Well, I don't see that there is going to be any shortage of work for people on the railway in years to come. Maybe I've just gone through the looking glass, but I honestly think railways are the future, and people are voting with their feet up until obviously the current situation. Ridership is higher than it's ever been, and trains are running more on time than they've ever been.
Yeah, it's like the COVID situation is an interesting one, and I know some people, rail commentators have got very excited and think we're going to have beaching too, and it's going to be a complete shambles and catastrophe. That just isn't. I just cannot see a world where that is accurate. We have a climate catastrophe ongoing. It's impacting this country right now. It's impacting lots of others. People are realizing that. People are aware of it. As you say, people have been voting with their feet. The rider, despite the fact that we have fewer 9 to 5 commuters, so season travel is reduced. Number of people who buy season tickets is reduced. Rail ridership has increased. It's actually increasing the number of people who travel by train because they've got more flexibility. They're maybe doing. So yeah, we're going to have much more. And then this crisis, I've digressed again, Melanie. I'm so sorry.
It's all right. This I can bring up that I'm supposed to be in Brussels today with my family, but our Eurostar. But it's okay because they've given us a voucher and we can go. We can go
afterwards. Yeah, and this is an opportunity. Yeah. Actually, there's an opportunity. So there are two things. Firstly, rail freight has the demand has soared, and it's shown how good it is during this crisis because we have a chronic logistics driver shortage. This is a running theme. Skilled people, we don't have many of them in this country anymore.
Yeah.
We don't have many HGV drivers. There's a massively diminishing pool, and they're all 50 plus basically. So it's a real problem that the industry has, and the rail freight helps that by the fact that you're not hauling one HGV load with one driver. You're hauling 80 HGV loads with one driver. That's a major saving. So freight is great. That's gonna, and then post COVID, how are we going to change that? We're going to re-baseline more freight, change the balance a bit. I think probably we will, which will only increase the stresses and demands on the railway. The other point is this is an opportunity for us as the railway. Once lockdowns start to send, normality starts kind of coming back, it's the time for us to say, actually, come to the railway. It's great. This is and there was already that reduction in the number of people flying across Europe thanks to Greta Thunberg. I think that momentum is only going to continue afterwards. People have really enjoyed their city centres being free of cars. I think there's just that momentum. It's a good time. Anyway, I've digressed again, Melanie. Sorry.
It's okay. I was banking on you digressing. So the kit we have on the railway at the moment, more than half is more than 30 years old. I would have guessed that it was more than that, but I read it on the internet, so it must be true.
Yeah.
Right, I think I'm ready for my next slide.
Oh yeah, go for it. I really enjoyed that slide. Oh, and they only get better because now we've got the. Oh, these are good. These are some cracking. So
and I'd like to say that most of these are pictures that I have that I've taken on site visits. The top left there, I went to King's Cross, and that was one of the most exciting hours of my life, being in the signal box at King's Cross. And I wanted to stand there like an idiot taking selfies, but I was too scared. It's a sort of dimly lit room full of very serious people doing a very tricky job. And I was just there to take a picture of the panel there, the light blue one that you can see.
Yeah.
Because I've been working on the Gospel Oak to Barking electrification,
okay.
And we needed to make some new Henry Williams. We needed to make panel overlays. So we needed to make a sheet of plastic to show where the electrification is on the new setup, and the sheet of plastic needed to fit on the signal on the console at King's Cross. So I had to go there with my 6-inch ruler and take some photographs of it to check we got the measurements right.
Yeah,
it was really exciting. So this is the interface. This is where our wonderful railway signals are controlled from. We've got lots of different kinds. The top two are route relay interlockings, and they are run on relays that weigh a kilogram. And they're called miniature relays. When you write a spec now, you still say, and we'll have 6 BR specs 960 miniature relays. And of course, they were miniature compared to the sort of black ones on the previous slide. They were miniature, and the name stuck. And they work by person pressing a button for the entrance and selecting an exit, setting a route, and behind the scenes, which we'll see on the next panel, you've got something that looks like Colossus at Bletchley Park, an electromechanical brain that is locking out. It's the interlocking. It's giving permission or saying, no, I'm sorry, you can't do that because we've got a train there. So that is taking the human out of taking the I'm struggling for words here. Taking the human out of the equation.
Yeah.
So the human is making a choice, but the computer can say no.
Yep.
And will not allow you to set that route. Bottom left is state-of-the-art Network Rail ROC, Regional Operating Centre, that works on computer-based interlockings. Hang on, what have I got to say about computer-based interlockings?
Now I'm looking at that. Is that what route is that? I'm trying to recognise the station layout, but actually I can't.
That's one of the ones that I did steal off the internet, so I honestly don't know.
Oh, it looks nice. Anyway, that's for me. That's quite familiar because you see the Network Rail ROC panels, the workstations. They call them workstations, don't they? Is that right?
Yeah, yeah.
And that style is very familiar now. The black screen with the cyan and the white text and lines all over it. And it's almost because that is based on what the original, the original what's it called? The original solid state interlocking that was introduced on the East Coast Main Line looked like that, and so all the new stuff now replicates that look, and so there's this lineage of sort of how this stuff looks to the operators that kind of you can trace right back to to 150 years ago. It's quite something.
Yeah. I absolutely love it. So that would be run by something like a Westlock or a Smart Lock, and those are all connected together by Ethernet cables on that internet. And at the other extreme, we still have hundreds of these lever frame signal boxes that I know you're very fond of.
Yeah, we had Tim when Tim was on a few episodes ago. He was showing us his pictures inside Severn Junction. Inside the famous Shrewsbury mechanical signal box, and with all the levers just stretching off into the distance, and there are loads. I don't know. Do you know how many there are in the UK? Is that a stat that's sort of easy to?
I understand it's hundreds.
I thought it was loads. Like hundreds sounds a bit loads because there's a lot to get rid of. and quite.
Well, the Victorians really went for it, didn't they?
Yeah.
They didn't have a population of 70 million and not in my back garden. They didn't have any of that, and they had buckets of money because when the Victorians were building railways, they were really excited because nobody had ever travelled that fast before, and people were just throwing money at them, weren't they?
Yeah. Labour was cheap, and you could build things really quick and easily.
Without any of this health and safety gone mad nonsense, eh?
Oh yeah. Who wants to save workers and stop people from dying?
I know, God. And thousands of people died making it.
Yeah.
I do find it maddening that people turn their noses up at, oh God, I can't believe I've got to wear a hard hat. Thousands of people died up until this moment. There's a reason you're wearing a hard hat and boots.
Yeah, if anyone I always say, if anyone uses the phrase health and safety gone mad, give them either a verbal or a physical slap. Because we're now. I mean, we've had a couple of fatalities for Network Rail recently, very tragically. But for quite a while, we had a couple of years with zero fatalities, worker fatalities on the railway. Which, if you consider that even 30 years ago, it was dozens. It was still a lot of people being killed every year on the railway. It's incredible. We have a phenomenally safe system. It's why, I've got up on my soapbox again. But a lot of people talk about roads, and there are all sorts of environmental reasons why roads are bad. But one of the main reasons why the future is not to continue to drive, electric vehicles are not a panacea, is because that doesn't take the human, as you've talked about, the human equation. The trouble with highways is that they're an entirely human-operated system. And ignore the nonsense about autonomous vehicles. It's a load of rubbish. People are still going to be driving cars in the future, and they're going to crash into each other and kill each other. We kill nearly in fact, what is it?
It's about 1,600. We're running at about 1,600
a year who are killed, and I think it's about 25,000 or maybe 16,000 a year in total that killed and very seriously injured. It's just huge numbers annually in the UK.
And I found out the answer the other day to something that had been bothering me for a long time, which is why rail crashes are such huge news, and it's because they're just not commonplace. It always sort of got under my skin that there's a well, there are very, very rarely any fatalities these days. I think the last one was Grey Rig.
Yep. Yep.
But yeah, it's always massive news. But car crashes barely make the local paper, do they?
Yeah, they just no one. I mean, you just don't see them. Yeah, there's no not because unfortunately we've been numbed to it, and people don't like being told not that the idea of their car, getting in their car is actually a death trap.
Yeah.
It's you know. Oh,
Gareth,
anyway,
have people started turning off yet?
No, in fact, we've got 70 people watching live right now. People love it, and we've only got 10 minutes. Theoretically, only got 10 minutes left, and your time is very precious. So I don't want to overrun too much. But equally, everyone always loves it when we overrun because people seem to enjoy an hour and a half of chatting about a railway subject. I mean, I certainly do, so I can't complain too much. Yeah. So sorry.
I'm just wondering how far to digress on this slide. Well, you can see the levers, and probably most people watching know this, but the levers operate the points and the signals, and the feedback mechanism is those block instruments that are on the shelf in front of the signaller there, and trains are announced by a bell. So the thing where you've got colour lights with the more modern systems, it's little needles on dials and bells for the old-fashioned lever system. May we have the next slide, please?
Oh yeah, certainly. Oh, just before we do, if it's all right, can I ask a question? Which is, how easy would it be for a signaller in front of the mechanical system there? So you can see that mechanical signal box. How easy would it be for them to transfer to another signal box? There are obviously things that are the same, but actually, is there a huge amount for them to learn if they go to another one? Like, are lots of things different?
I don't know. I was reading an accident report in preparation for coming on here today, and it does seem that they have very, very individual systems for each signal box. But at the same time, with the COVID situation, they've been retraining retired signallers in 2 weeks. So maybe not that much.
Yeah,
I honestly don't know.
It's interesting, wasn't it? Yeah. Anyway, right. Next slide. Okay. Oh, it's even. Oh, we were talking about Colossus, and we're starting to see. Here we go.
So that in the bottom in the middle, that's me. This is me in my signalling designer. Hardly ever go out on site. Really clean PPE. If you Google engineer, this is something I put in my talks to school kids. You always get someone in a high-vis vest and a hard hat, and that is about me twice a year.
Yeah.
I very rarely leave the office. I do love leaving the office, but it just doesn't really come up. I sit in a nice warm office and design things for other people to go out in the cold and rain and scorching sun to go and install. So the thing I'm standing next to there is me with the miniature relays. So that is.
We're almost doing rabbit ears around miniature at this point.
Yeah. And that is post-war up until the 1980s. That was the standard system, and I've done an awful lot of work on those because they're becoming life expired, and a lot of the work I do is renewals.
Yeah.
So we're upgrading those. On the left there we have underside of a lever frame, and I did a Google image search for these, and everybody takes pictures of the lovely picturesque levers in the quaint box, but there are very few images of the undersides. There are some on specialist websites, but I didn't want to pinch any copyrighted images, so that a friend sent me that. So that is literally the sliding metal rods that will lock each other out to stop a train going into the path of another train.
So is that the mechanical interlocking? Is that what we call that? Yeah. Okay.
Yes. Well, actually, I don't know what that's called. Yeah, it's called the dogs.
Okay. But it's a rare view, as you say. It's a rare view. People, as you said, focus on the levers up top, but actually, the really interesting, if you like, the computational stuff, the logic gates are the things, those rods, the sliding rods that do or do not let each other be moved. It's fascinating to see it, and it is that, isn't it? It's logic. It's a series of logic gates. It just happens to be with big bars of metal rather than a computer brain.
absolutely. And the blue on the in top middle there,
Oh, yeah.
those boxes hide those sort of copper metal fingers, and that can be the interface with the electromechanical. So that's going from purely mechanical to electromechanical, and driving relays with those fingers. So
Okay.
contacts are made and broken as you pull the levers. And on the right there you have it's a SSI module, an SSI location, and that was I did a bit of work on Crossrail, and that was before it went over out of program. The bit I was involved with was completely delivered on time, and that is a very modern West Race, an SSI, and that is a sort of industrial computer that relies on 2 out of 2 or 2 out of 3 voting to.
So there's the redundancy in the system, is there?
So you don't get the spinning wheel of death
Yeah,
on that kind of thing.
yeah.
If
The
one
last thing
gets
you want is a spinning wheel of death of a computer
Yeah.
deciding whether to put a red light in front of a train, right?
Yeah. People sometimes ask why can't we just run this on a PC? And how many times has your PC crashed?
Yeah.
And how many? Do you remember Windows 95 and Windows 97 and Windows 99? And it's not reliable enough, and it.
And the fact is, these are going to, as you say, these are going to be sat there for another 40 years potentially. So they have to have that. They have to have the same level of redundancy built in that the kilogram-sized miniature relays had.
Yes. Yeah.
Yeah. And it's and so that I suppose that as we've got a more intensive, it's not that there's a quantum more calculation that has to be done as we're running our railway more intensively as well, right? So it's not just that it's like for like, but these systems are having to do lots more calculations than the old relays had to.
Often, yes, yeah. Maybe have the next slide.
Oh yeah, sure.
God, I can't believe it's 3 minutes to 8 and I haven't explained the track circuit yet.
This was always going to be the case. Oh, I'll tell you what I'm going to do. Well, very quickly. We had a question earlier, which was a really good one. Sorry, everyone. It was 3 minutes to the hour, but it's fine. We had a question about wrong side failures and signals passed at danger, and I thought it's worth explaining the difference between those two things, because one of those isn't actually a failure. It's a failure on the driver's side rather than I'll let you explain the difference between a wrong side failure and a SPAD, a signal passed at danger.
Well, yes, a signal passed at danger is literally that, and the track circuits or whatever mechanism you've got after the signal will detect that the train has gone past, and that will create a hopefully the train has realized that they've gone through the red light, and they will have stopped within the overlap, because every signal has a 200 yards 180 meter overlap beyond it to take account of the train not stopping. So hopefully a SPAD, it can be a wrong side failure, but hopefully we catch it within the overlap, the 180 meters, and it is a right side failure. But
the wrong side failure is where our signal is showing something. Is showing, generally it's where it's showing a go where it should be showing a stop. So a stop where it should be a go is annoying but not dangerous. A go where it should be a stop is dangerous because you're putting a train where another train might be, right?
Yes, absolutely, yeah.
Yeah. Google Clapham Junction rail crash or Clapham rail disaster, and then you'll find out all about wrong side failures. Okay, conscious of time. Thanks for that, Melanie. That was answering Will's question from ages ago.
This is like being asked. So I sat my driving test in, I think, 1991. What's the stopping distance in the damp at 30 miles an hour?
Right. We're already okay. Firstly, sorry, Melanie, that we're running over for your time as well. But you don't mind. You don't mind too much, do you?
No, I don't. Not at all.
Cool.
It's such a privilege to be here.
No, the privilege is ours. We're learning many things, and track circuits is going to be the next thing.
Yes. So track circuits. where we are using the rails as part of the circuit. Now, Gareth, what are train wheels called? What's the technical term?
A wheel set is
The wheel
one,
set or bogey. I
or the
prefer.
bogey. Yeah, sorry,
Yeah.
bogies. Yeah, is that because
So
is that the line you use when you're doing for the under 12s where we all
yeah,
giggle?
under
Because I
12s.
bet 50% of people watching this now giggled because we've said the word
Yeah,
bogey.
she said bogies. Yeah. Well, you want people to remember you, don't you?
That's it. Yeah. So if you shout bogies at them, that's a good way to do it.
Um, so the track circuit in its most basic form, and this hasn't altered very much from Victorian times, except we do it a lot more efficiently now. You feed a electrical current through the rails, through the actual permanent way rails that the train is sitting on, and you are so you've chopped your P-way up with lots of IRJs.
Yep.
Just to annoy the P-way engineers, and you've made your little block, and you are feeding a current all the way around that block. So at one extremity you've got your power source, and at the other end you've got a relay that you are holding up with that current. So that current is going through a little magnetic core, and it's holding the relay up. And at that point, you've got no train there. Your track circuit section is clear. Now, when the train comes along, the current finds an easier path through the bogies, and the relay drops because the current that was holding it up is suddenly going through the bogies, and the track circuit drops. And that is the most important relay. It's called a TPR. And when your TPR drops, you've got a train on the line, and your signal is displaying a stop, or one of the other colours that they do that isn't green.
Yeah.
Because that's how you dead reckon where your train is. Okay. What else do I have?
So it's worth saying. So you might have said IRJs are insulated rail joints. So you can see on the top. In fact, both of these pictures, there's an arrow pointing to insulated gaps. Insulated rail joints are generally a very strong, generally a 6-hole rather than a 4-hole fish plate. So the fish plate's where you bang them either side of the. If you're looking down at the rail in plan view, you bang a fish plate either side of the rail, bolt it together. But you've got an insulate. Generally, it'll be glued and insulated so that the electricity
can't. Do you want
can't
to go to the next
from one rail
slide
to the
because
other.
I've got a picture of one.
Oh, amazing! Here is the next slide.
Hang on, that's not the next slide.
Oh, have I missed one?
Well, maybe I didn't send it to you. I was doing this rather late at night.
Oh, people can search insulated rail joint and there'll be loads of pictures.
Yeah.
Google it, everyone.
Yeah, I mean it's not really a great thing of beauty, but here are some little plans that I've done showing how many little insulated rail joints we put in, and insulated rail joints are they're not ideal because am I right in saying they weaken the rail and they require maintaining? And
they do, yeah. We don't like they're a weak point. You're introducing a joint. Whenever you do that, we like to have nice, long, continuous rails. Whenever you introduce a joint, it's a weak point. It's a hinge, and so whilst modern insulated rail joints where you have 6 holes rather than 4 as a traditional fish plate, they're pretty strong. You've got good strength, but if you've got complicated switches and crossing layouts. Then actually you can struggle to fit those 6-hole joints in, and you end up with 4-hole insulated rail joints, and they're weak, and eventually they break to bits, and you need to replace them. So you're introducing lots of weak points into the system, but obviously you need it to make the railway system work. So it's a compromise.
Yeah. On the bottom drawing there, we've got loads and loads of IRJs to make that complicated little piece of railway work. So that's the basic DC track circuit. It's adaptable. It works in AC traction settings. It detects broken rails, which used to be a real selling point. Apparently, you used to get hundreds of broken rails every year, and it was useful to know where they were.
Yeah, definitely.
But these days, because everything is manufactured to so much a higher standard with modern techniques. And of course, the flying banana going around checking for cracks. They are way down. I had someone on the internet guess that there are about 100 a year in the UK now. So that's not really a selling point for DC track circuits anymore. They're relatively cheap, but the shortest. You can have them as short as you like. You can chop up your railway into sections that are just as long as your train. But the longest possible DC track circuit is 1,200 meters, and that is sort of downhill with the following winds. If you want it on wooden sleepers in the wet, 700 meters is as good as you'll get.
And is that just because of the amount of voltage or the amount of current that gets put into the rails? Is that essentially what limits that length?
It's leakage, so you get a resistance. The current leaks out, and you might not have enough current to hold that relay up.
Yeah, okay, yeah. So someone did ask how much voltage or how much current, I suppose, or both, is actually being put in for DC track circuits. So what's the voltage of a DC track circuit going through?
They generally work. We call them medium voltage. So that is between 24 and 50 volts.
Yeah.
When I do careers fairs, I have this hulking great piece of low voltage railway signalling cable, which is like diameter of a really fat stick of rock. I just stand there with it and offer people to hold my low voltage railway signalling cable. So yeah, they really are quite low voltage, between 24 and 50 volts. And I don't think I've got anything else to say about those.
David Shepherd has said, is this where we were going to talk about long trains on 2 blocks? So one train occupying 2 signal blocks, double blocking.
I have to hold my hands up and say I'm a Grit 5 designer. I don't get involved.
So someone had asked what happens if one train can fill up 2 track circuits and
well, when you're designing a bit of railway, you take into account the longest trains. So someone will have designed the control table for that piece of signalling, and it will be expecting that sometimes you have 2 trains straddling track circuits. And of course, when it's even if you've got really long track circuits, you're going to be in 2 track circuits, aren't you? Because there has to be a point where you're
there'll be a point where you're transitioning between 2, and so essentially you're blocking 2 very briefly for the time it takes that train to move over the IRJ. You're blocking 2 track circuits, right?
Yes, and so sometimes if you're sitting on a train, you might think that you've passed a red signal because your bogies will have passed over the IRJ into the next track circuit, but it will
trigger the red, and you're passing, and so the red's showing despite the fact the train is next to the signal at that point.
Yes, because it's made it go red to say because it was green a minute ago. The driver's looking at it, green, lovely, let's go. But as soon as you go into the next track circuit, it's red. Yeah. So person behind can't crash into the back of you.
Yeah, and things get fiddly. So I was doing some work on a mixed system of Nexus, so the Tyne and Wear Metro, where they have they have signalling, their own special signalling, combined with allowing network rail or allowing heavy rail freight trains to run on it. And that was a very interesting and complicated signalling chat that I was privy to because I was doing some of the engineering management on it. And that they were talking about things like double blocking and all sorts of clever things to treat. I mean, we could talk for hours about it now, I'm sure, but I mean, things get more complicated than you've shown us in the sort of simple slides here in terms of track circuits can get fiddly. Okay, so right. We've had a few questions about different ways of marking track circuits, but I feel like you might answer that one in a slide to come, so I'll park that for now.
Okay, yeah. So we love to put IRJs in and upset the POA engineers, but of course you can have AC track circuits now, and I've got some examples of AC track circuits top right there.
Oh, okay.
Those work on tune zones. So you do still need some IRJs to stop the current leaking out if you're in an electrified area, and where you really, really need to know where the train is within millimeters, you still need IRJs because the AC track circuits work on audio frequencies, and you're literally tuning the rails. They're still forming a circuit, but it's an impedance, and the bogies of the train still knock it out and drop the track circuit. But it does have this beautiful thing that you don't have to have IRJs. But the downside is that it's a bit more floaty, and there is a zone of about 20 meters where you might not be sure where the train is, and often that is not good enough.
So is that generally better for rural systems maybe than?
I don't know. I mean, you can make them longer. They can be up to 2 kilometers longer.
Okay, yeah.
I mean, rural, I would say you'd want axle counters.
Yeah, okay, yeah. Because actually you want your blocks to be multiple kilometers long, perhaps.
Yes, yeah. Although they have a downside as well. They're very reliable, but when they go wrong, you have to send someone out to manually reset them and check there's not
a thing.
A part of the train. Yeah. So there are about 50 kinds of track circuits, and these are the sort of greatest hits of track circuits.
Yeah, okay.
And it's horses for courses.
So the one you've got on the top left there, are those treadles or axle counters?
They're axle counters.
They're axle counters, okay, yeah.
Yeah. And they're increasingly being used in complex areas. So I think traditional track circuits are slowly dying out. But it's like mechanical signal boxes. They're not dying out that quickly.
Yeah. There are still, like 70% of the network on traditional track circuits or whatever, who knows. But like a lot of the network is still on the old, in fact, a lot of the network presumably is still on the old DC track circuits. I mean, is that still the majority system, you think, in terms of block separation?
Everything I look at has a mixture.
Ah, really? Okay, interesting.
Yeah.
Because that's true. Because when I'm out on site, obviously, when you go out on track, you have, as part of your briefing, you generally are told what the signalling system is, so that you don't trip it if you're pushing a trolley through. So track circuits is not a big deal. Trolley doesn't matter. If you're with an axle counter, more problematic. You might start sending funny messages to places, and treadles likewise. So. Oh, and treadles are worse because you need to go and find the other one and tap it back out again. And I have to say, it's about a mix. I think it's probably about 50-50 that I've seen of a mixture of axle counters, but that's not the overall network. That's just in my small little sample size of what Gareth Dennis has been out and looked at. Anyway, right, okay, so let's
move on.
Yeah, let's move on, because crikey,
you could fill up a presentation or an hour with any of these topics.
Yeah.
You really could. That's my there's the IRJ.
Did I just get the slide order wrong? That might be my fault. Sorry.
It's probably my fault.
Anyway, there is one. That is a in situ formed 4-hole fish plated IRJ. That's not bad. There we go. You can make that on site, nice and easy, but it's not shock glued, which means it's not quite as good as one that's been manufactured off site and then brought in as a single piece. Yeah,
you can see they've got their massive spanner there tightening up the.
That's it. Yeah.
And the top right there, we've got something from the train detection handbook, which is showing you an example where you might need IRJs. You might need to precisely know where your train is, and not have it past the clearance point or the fouling point. You might want it. You've got to have it resting. I think it's 1,766 millimeters away, so it doesn't. The train coming through won't strike the train waiting to come onto the next line. So IRJs, I'm afraid, are necessary.
There's always a need for them. Always wanting to muck around with the P-way, but frankly, it's a compromise I'm willing to make if it avoids us bumping trains into each other when they're converging on a junction.
Yeah. I think we'll just gloss over all this complicated stuff at the bottom. This is some bonding, and this is something I've done a lot of in the last 5 years. And it is almost as complicated as it looks. This is how we differentiate the signal that is detecting where your trains are from your track circuit with one set of rails, and taking your traction current back to where it's come from, your high voltage, 25,000 volts, back through the rails.
This is always the black magic that really, whenever I think about track circuits, this is the bit that always stumps me, which is that you've got return current from the traction system, and you've got a current within for the signaling system as well, and how they interact, and that's how anyway. So
and one of those will very much kill you. The other one will do you to fingernails, won't it? yeah, so that's what I've been working on, trying to get the traction current to work with the signalling system.
Yeah, yeah. So,
Um,
shall we go? Yeah. Do you want to pop
yeah,
on to?
please do, yeah.
Yeah, cool. Ah, okay, right. Level crossings.
Oh my words. Um, for us to come up with a system for so level crossings are the most dangerous thing on the railway network, and we are not allowed to have any new level crossings because they are so dangerous. And there are about 3,000 incidents, unsafe incidents, on UK level crossings every year. They're a flaming nightmare.
Get rid of them all, please. Yep.
Yeah, have a nice. You could do the Dukes of Hazzard, as I've illustrated there, or maybe a tunnel or a bridge, depending on how.
Trebuchet would be good. Trebuchet would potentially be safer. Yeah.
God, I don't think we've got time to talk about it. I don't have anywhere to be, but I'm actually bored of the sound of my own voice.
Well, no one else is. Everyone's loving it. But I agree. I mean, we could talk about level crossing for hours. So yeah. So I suppose, yeah. Tell us about. Well, there's a picture of you stood next to something marked Honeywell.
Yes, that is about 10 years ago. That was supposed to be the thing that was going to get rid of the person in the signal box.
Oh, actually, I'm going to get rid of our faces so that we can see both, because hopefully your sound will still work, because my face and your face are in front of your other face in the picture. Wait a minute. I'm going to go for this. There we are.
There I am. Can you guess what the tic tac is? Oh, I've said it now. It's a tic tac. It's a giant tic tac.
Yeah, it's a giant tic tac on a stick.
And is vandal proof. And if you were to hit that with a hammer, the hammer would bounce back in your face.
That's good.
So no hitting with hammers, kids.
That's
and we installed one of those at a level crossing in South Wales, and inside it is it's a radar, so it's detecting anything that might derail a train. So that is something that is I think 0.5 meter by 0.5 meter cube made of metal. So a car is obviously well within that, and it does a very good job. It can detect a car or a floating metal cube going through the level crossing. And the difficulty was that we had to make it work with a little LiDAR, a complementary system. And that's where the diagram bottom right comes in, of the small person lying on the floor. The LiDAR had to detect the smallest centile 9-year-old child that had fallen down on the level crossing. So both systems had to agree. But the LiDAR was very, very sensitive to crisp packets, leaves, coffee cups, and we had a hell of a time. I think our testers were down there for months trying to get the two systems to work together. Going through.
When I was at Atkins, I worked on quite a few level crossings, and I remember the LiDAR system being problematic. Getting the LiDAR system. I think they were trialing it on a few sites. One of the level crossing gurus I know is a man called Phil Askey, and he's sort of one of the he worked for British Rail, and he's sort of one of the he's very good at level crossings, and he said that the systems are good, but it's just one of those situations where you have complicated systems all talking to each other, and I think it was hard getting the LiDAR to not just close the railway all the time.
Yeah, it was like a really officious sarcastic robot in I don't know, any number of sci-fi.
Yeah, you've got. I've had a mind blank too. I was trying. Is it Marvin? Don't want to say Marvin.
Yeah, Marvin. Yeah,
that'll do. Hitchhiker's depressed.
Marvin was really annoyed at the doors on the Heart of Gold.
That's it. Exactly.
The doors kept offering him cups of coffee, and
that's it. Yeah. Level crossings.
Anyway, there are about 100 of those LiDARs. Those LiDAR obstacle detectors.
Yep.
In the UK, but I'm not sure if they're ongoing, and there are new systems coming in all the time.
Because this is
to hopefully take the error out of the system. And just very quickly, I'll tell you about the signal blocks on the left there. That's a place called Tram Inn, which is in the Welsh Marches, and we did a job for Network Rail after the Moreton on Lug accident, which
Yes.
is an absolutely tragic human error, where the guy operating the signal box had been on the phone to a farmer on his user work crossing, and the farmer was very keen to take some sheep over the level crossing, and the signaller saying, I'm not sure you've got time before the train, and can you ring me back in 5 minutes? And the farmer rang back, and basically the guy's been too distracted by this guy wanting to get his sheep over the line, because we're all in a hurry, even sheep farmers, and he thought the train had gone, and he raised the barriers and the train had not gone, and the train unfortunately ploughed into 2 cars and someone lost their life. So absolutely tragic accident. So we were asked to come up with a solution to ensure that the interlocking would not let you raise those barriers until the train had passed. So we fitted treadles on 6 level crossings in the area to make sure that never happens again.
Yeah.
So it's once again taking the human. The human still got their job, but it's just one fewer mistake that they can possibly make.
Yeah. Yeah. And it's interesting because I didn't realize how many level crossings didn't have treadle protection, but there are quite a few. I mean, I don't want to put a number on it, but so I've done level crossings jobs down near Great Malvern, and I've done level crossing jobs up on the Settle Carlisle line, and there were some that had treadle. So treadle where you've got a little ticker, it just counts the number of axles in and counts the number of axles out. Very straightforward. But I didn't realise there were so many that didn't have that protection in place, and it relied entirely on the signaller in the box. Which feels in today's day and age that feels like a crazy thing to do. Like, there's no protection for that worker who might, who, as you say, is being distracted by things happening all at once. Invariably, the moment when the accidents happen because everything's happened at once, and this is what happened at Morton. Yeah. So right, shall we pop on to the next slide?
Yes, please. Yeah.
Right. I see vehicle envelopes. I see gauging. This is exciting. You put this one in just special. No, you haven't.
Well, actually, I didn't know that you were into gauging, but
that's a strong way to describe it. But
I just threw this in because it was a really lovely little job I did last year. One of the frustrating things about being a signal engineer is you very rarely get to be really good at something because there's such an enormous variety. I mean. But this was a lovely one. This is in Heathrow tunnels, and if you can see on the left, there's a fibre optic banner repeater signal. So the tunnel's slightly curved, and the driver cannot see the red signal or the green signal around the curve. So they put these banner repeaters in, so that the driver knows that there's a red signal coming up around the corner, and they have to start slowing their train down. And it seemed like such an easy thing to do. These signals, as you can see on the right, they're 30 or 40 years old, and the worry was that they've run out of spare parts. They've cannibalized every last one they can get their hands on. Nobody's making them anymore, and they just wanted to replace those little signals up on those shelves. And actually, when you consider all of the things that a signal has to do, it has to have a range that is hundreds of meters, and it has to be, 30 centimeters square. You can see on the little envelope drawing there. On the left, there is a bracket. That is how far that's how much you've got to play with. You've only got very few centimeters, and most signals size isn't really a problem. They're like the size of a television. And the smaller ones, they don't have the range required because these Heathrow Express trains are going pretty quickly. So in the end, I worked out that we could, by just adjusting the eye level slightly, because a committee has to go out, and
signal sighting committee,
and they have representatives from the signalling engineers, train drivers, the train operating companies, and everybody has to decide that is a suitable position for the signal, and the driver's eye level height is a really crucial dimension. But I worked out that if we got a bigger one and stuck it slightly lower and slightly in, we could get it in. But I just love that they can't just go and buy an off the shelf one because it's such a specialist piece of equipment. I suppose I shouldn't love that, but it keeps me in a job.
So the bit of signalling kit that I have, particularly on the southern region, the bit of signalling kit that I have the most trouble with not hitting is the MARI, the multi-aspect route indicator.
Oh yeah.
So that's basically a box that you think is quite small, and then actually you measure it, and it's like 250 mil by like 400 mil or something like that,
yeah.
which is quite big. Particularly when it's in the middle of a very narrow 6 foot, so that's the bit between the two tracks, on a really tight curve on the approach to Portsmouth Harbour. And they've got these things sat on top of the ground signal. So you've got a ground signal, a conventional, the sort of 3-dot thing, and then the box, this MARI, this box sat on top that just annihilates the gate. So you can see the bottom corner of this kinematic envelope on this screen.
Yeah.
Here, well, if you've got, I'm going to do pens now. Here we are. If you've got a multi-aspect route indicator that kind of looks like this,
can't you use a smaller train?
Well, this is people. It's like they're like, oh, can you not use a smaller train? I'm like, well, I can try. So, and this thing basically just says off.
Yeah.
Pretty much all it's there for is to say the word off. There's my dreadful sketch. But they're always just in the way. And so we were playing with moving them and putting them in front of or behind. And to do that involved such a complex process. I mean, rightfully so, because it's an important part of the protection for operating the railway. But the signal sighting committee for that was pretty rigorous.
Well, this all feeds into why is it so difficult, and why is it so expensive? It's just because it is difficult and expensive because you've got a lot of things to think about if you don't want to kill someone.
Yeah, exactly. It's a huge. The railway is a hugely complex system, and every little change you make has a knock-on effect. And and getting the right people in the right place to understand what those knock-on effects are is challenging. You have to train these people, and we have a chronic engineering shortage, so that means it takes more time because everyone's got a full email inbox. They're at meetings all day and don't have time to actually do the day job, and no new or not nearly enough new engineers are getting trained.
No, we need UK engineering needs 200,000 more a year.
It's an inconceivably large number of people. 200,000 new engineers across the engineering sector. It's just staggering.
Can I just do a shameless bit of self-publicity here?
Yes,
I won. I didn't win. I was runner-up, Rail Engineer of the Year 2018.
Amazing.
It is amazing, and it is flaming brilliant. But I won, or I didn't win. I was amazed. I got second place. Proper engineer, got first place.
You're
but
a proper
it's because I do a lot of outreach work. And I could happily go and stand in a school hall once a week, and still have requests to go and talk to people and do events, because you can't be what you can't see.
Absolutely, I couldn't put it better.
I don't imagine many 11, 16-year-olds are watching this, but people's parents are, and it's the parents and the teachers that you've got to get at. You've got to sow this idea. When your teenager is saying, well, I'm not sure what I want to do, you say, well, have you considered a career on the railway?
Absolutely.
So everybody watching this, if you've got children that don't have a direction yet, bear it in mind. You're pushing at an open door. We absolutely need younger engineers.
Absolutely.
Because we're getting old.
Yeah. We're all. Yeah, I mean, we're all overworked. I mean, I say you could write a blank cheque to do everything the railway needs tomorrow. The government could literally write the railway a £1 trillion cheque, and we would deliver everything pretty much at the speed we are now, because the shortage isn't money. I mean, the fact that money doesn't exist is a discussion for another day, but the shortage is engineers. We're doing as much as we can already. If you look at the overtime sheets of all the signalling engineers across the country, you'll see how short we are of signalling engineers. Right. What is the next? What's the next slide?
I think that's the end. I think that's the end.
So if I go to do this, it is the end. Oh, that's kind of sad. Melanie, that's been so good. We've run horribly over time, as ever. It's been so good. That's been really terrific. We've covered a lot of ground there.
I feel I've done justice to nothing, and I think a lot of people are going to be tweeting you saying, oh, I think she got this little bit wrong.
No.
But I hope that is like introduction to railway signalling, and I'd be very happy to answer any queries and do some googling if you've got any questions.
Yeah, we've to be honest, we've got most people are quite content. I think we haven't got any. Oh, could the specialist kit Melanie was talking about be designed to be manufactured on a print-on-demand basis?
It has to go through product approval. So I did look at this, and I was in touch with a couple of the major manufacturers, and the price is just through the roof. It's tens of thousands of pounds to get product approval on something.
Yeah, it's often referred to as the bane of the industry, is the fact that you've got to get through product approval for any new gizmo or gadget. Thanks for the question, by the way, David Shepherd. But it's just as we've just been saying, everything has to work. It has to show that it will work as long as it says it will work, that it won't interfere with all the other bits of kit. So the product approval process, we can't just get rid of it, because then you'll have all the problems that process is designed to avoid, which is, technology getting in the way of other technology and so on and so forth. Yeah.
Good question. Thank you.
Yeah, thanks, David. Good question. What else we got? Oh, everyone's making the normal joke of, if you've got two engineers, of course it's normal to overrun. Yeah.
Has anyone asked about leaves on the line?
No one's mentioned leaves on the line, although every time I am late for putting a video up, someone makes a leaves on the line joke. Ben has said that got the 16-year-old daughter to watch this one. Says that Gareth definitely looks like a Gareth. I don't know.
That's a compliment, right?
Yeah. But she's not convinced about her career in rail yet. Well, we'll just have to do another one and keep convincing.
Well, yeah, follow the money.
Yeah, that's it. Oil.
If an interesting, rewarding career where you get to tell a load of people what to do isn't up your street, then maybe the money. The money's not bad.
The money, particularly the money is much better in signalling than in P-way. Everyone, if you want to make money in the railways, become an S&T engineer. Right. That's right. Okay. So I think considering where we've gone time-wise, which is horrendously overrun, and Melanie has very kindly hung around for an hour and a half or more, because we've been on the call for a quarter of an hour before that as well. Let's, without further ado, go back to here and say thanks everyone for following as ever. A pleasure on the podcasts. So iTunes, Spotify, Heel, thanks very much indeed. Google and the other one. So thanks for listening. Hopefully we described this well enough. Give feedback. The adverts are that next week. It's a bit of a Dr. David Turner and Rail Natter crossover. No pun intended, honest. I'm on the Transport Tavern on Monday evening talking about continuity and change. So how practice has changed over time, and how history has informed what I do nowadays as a rail engineer. So kind of relevant on what we've talked about a lot. In fact, a lot of what we've covered today, Melanie, actually, is how everything is fed from the past. We learn everything has been fed by some change, some problem, some accident in the past. So that should be good. And then likewise, next Rail Natter is the one that a lot of people have been asking for. So we've done two of the biggies. Signalling was like the number one thing everyone wanted to hear about, which is great. And number two is beaching. So we're going to talk all things beaching, and I've got Dr. David Turner joining to sort of add some historical context to some of the things I'm going to say about beaching. So enough about the adverts. Join us next week for that Rail Natter. Obviously, I give my Patreon plug, but also go and follow Melanie on Twitter, Miss Melanie Osborne, for all sorts of this sort of stuff. Insights galore, lots of STEM stuff, which is really good. This is where you get to vote on future Rail Natter themes, but quite enough about that. Melanie, thank you so much for an absolutely smashing Rail Natter. That's been brilliant. I've loved that. I've learned
thank
so
you
much.
for having me. It's such a privilege to come and talk about something I really, really enjoy.
I'm glad that I'm glad that we're starting to get some learning out. I'm learning things. Everyone's learning things. And when we move on to like detailed ETCS and ERTMS, we'll be getting you in for a reevaluation, and we can cover some of that. No, it's been brilliant. It's been really good. Thanks everyone for watching. It's been a good fun one. Lots of questions, lots of chatter. We've had like 100 people watching this one live, which is great. It only remains for Melanie and I to say thanks and cheerio. Cheerio.
Bye. Thank you.
Bye.